So far, we've looked at variables. So we looked at var and val. Var being something that we can change. So we create a variable and we attach var. Then we can always change that variable at a later time. Val, on the other hand, we cannot change. So it is immutable. The great thing about variables is that they allow us to store pieces of data. But the other side of the variable is that it only allows us to hold one item at a time. Now, although this is okay for most of the things that we've been doing, but as you learn more about programming, as you learn more about the power of Kotlin, and you start putting together more complex programs, you will find yourself needing something that can hold more items. That's when collections come to light. What is a collection? Well, a collection, first of all, will allow us to hold a collection of items. So let's take a look. A collection, by definition, usually contains a number of objects or items in a certain order of the same type. You can think about a collection that you may have of, let's say, dolls or a CD, right? And usually what you want to do, or what you usually do, you organize your collection into different kinds of items. So you could have a collection of CDs, and then you can have a collection of dolls, you can have a collection of cars. So you notice that each time I say a collection, I'm saying that you have a collection of X, a collection of Y, a collection of Z. So those are the types that we will have in one collection. So you have CD, that's one type. You have cars, another type, and dolls, another types. Okay? So that's the idea when we talk about collections. Now here is a visual representation of what a collection in memory would look like. You know, there are different kinds of collections and we see those, we'll talk about those. But in a nutshell, in memory, we'll have something like this. For instance, you have 23, 123, 13, 98, 6, and so forth. So this is a collection, in this case, of integers, numbers. So in memory, each one of these items, we call them elements, right? So if I say, what is the first element or first item in this collection, we would say 23. And what is the last one is going to be number 4. So these are called elements. And the great thing about having a collection of some sort is that each seat, if I may call it, right? Each slot, if you will, it's called an index. So an index is the slot where the element sits in memory. So the first index starts at 0. So that would be index 0. If I say, what do we have in index 0? We will have 23. Index 1 will have 123 and so forth. So that is the visual representation of a collection. It could be a list, array list, and list of, and so forth. Now, like I say, there are different kinds of collections, but this is the base of collections, where we have elements inside of slots that are numbered into index, that are numbered as indices. So index 0 is going to be the first slot, and 1, the second slot, and so forth. Let's go ahead and see how can we create a list or a collection, a basic collection, so we can start adding things to it and loop through. But before we go forward, also, you will notice something that's very interesting. A collection will have what we call a length or a size. What is that? So a length or the size, in this case, is going to be 6. So length or size is the number of elements in the collection, not to be confused with the index. This is just how many slots we have inside of our collection, right? In this case, we have 1, 2, 3, 4, 5, 6. That is indeed the length or the size of this collection. All right, so now let's go back to our code and see how can we put together a simple collection so we can see how this works. All right, so how do we create a list of items? Okay, let's go ahead and get started here. The most simple collection type, in this case, I'm going to create a read-only collection type. So what you do is, let's say file, say my list of names, and then I'm going to just say is equal to list of, just like that. And of course, you can see there are different options here. Notice these are all functions that we get from Kotlin. So we want the second one. Either one would work, of course, but let's just get the second one there. And inside here, we can pass elements, right? We talked about elements. Those are items that we can pass inside. Now here, I want to pass a string type, right? String types inside of this. So I'm going to say James, Paul, Raphael, and Gina. Okay, so there we go. So we've created a collection list here. And one thing you notice is each element or each item is delimited by a comma to say now this is index 0, index 1, 2, and 3. Now, quick question. What is the size or length of this list? Yes, it's going to be 4 because they have 1, 2, 3, 4. Okay, so let's see. What if we wanted to, let's say, show the contents of this list? What do we do? Well, we can go ahead and say print. We'll show you real quick. I'm going to just go ahead and print out my list of names. And if we run this, okay, so a few moments later, you can see that we have indeed James, Paul, Raphael, and Gina. So this is the internal representation of this. Now, if you are coming from a different programming language or other programming languages, you'll see that this is very familiar because we have these square brackets here. This tells you that this is actually saved as an array, right? So an array, it's another implementation of a list, if you will. Anyway, so there you have it. Now, we can actually loop through all of these names and spit out each one of them. How do we do that? Well, we can go ahead and use a for loop. Let me go ahead and put this back like this so I have space. I can say a few things. First of all, I can just say a for loop like this. I'm going to say item in my list of names as such. And what we're doing here now, we are saying for each item that we get inside of my list of names, it's going to be added to this item variable. So now this item variable, as you have over, it's actually going to be of type string because it knows that this list of names contains strings. So now I can say print item, let's say print ln, so that we can have a line break. Let's go ahead and run. And you can see now we are going through and getting each item of our list of collection there. And of course, because we know it's a print ln, we can also interpolate a few things here. I'm going to say names and pass item as such. You can say the same thing. Let's go ahead and run from here. Same thing, run. And you can see names are showing there. Another way we can loop through a list, we can use a for each. This is very special because we can actually use this my list of names at the top here. I'm going to say my list of names, and because it is a collection, I can invoke a method. I can dot, say for each, and voila, you can see now, look at the beauty here. We have a few options. What does this look like? Right, if you said lambda, you are completely right. We do have a lambda for each. Let's try it out. So click like that, hit enter. Aha, look at this. The moment we hit enter, remember we have the it type variable argument that we are receiving there. This is equivalent to this item, which means that's why it's string. So now we're saying for each item, as we go through this my list of name, right, we're going to receive an item or a string item or a string element, in this case in the form of it. So if I just go ahead and then print it like that, what do you think is going to happen? Let's go and comment that one out so we don't have duplicates. And you can see James, Paul, Raphael. Let's say print ln again. That way we actually get something that it's readable. Okay, James, Paul, Raphael, and Gina. Very good. So we have two ways to loop through or iterate through our list of. Now, you may say, okay, how do I add dynamically to a list of? Well, you can't. The reason why is because there are two types of lists in this case, or two types of collection. There is the mutable type, which means just like val or var. So var in this case is mutable. List of is immutable, meaning you can't change it. You can't add anything to it unless we go up here and add manually, because the size of this is set right away as we add each item. So we can't say my list of items and dot add. That's not going to work because it is indeed immutable. If we want to create a mutable list, then we'll have to say something like this. Val my mutable list items, just my mutable list, and I'm going to say is equal to mutable list of. Again, the same concepts here. We want to pass elements going to say, in this case, I'm actually going to change this instead of having string types, right, in our list for its items. I can put numbers. So 12, 34, something like this. Now for this mutable one, let's get rid of this. I can do something else, right? I can say my mutable list dot, and I can invoke the add. Right, so I'm using the wrong one. That's why I can't access the add. My bad. So this has to be my mutable list. There we go. Dot add. Then I have access to add. And you can see here I have a few options. I can pass the index. Remember the index, which is the slot where we want this element to live, right? To sit in a way. So in this case, if we just put the actual element, the item or this element will be put at the end of the list. Okay, so because it's expecting integer, you can see element has to be int because it knows that we have integer that we've added. So in this case, let's say something like this, and let's go ahead and print my mutable list like this real quick so see. And you can see, like I said, the 124 or 214 that is, it was added at the end. Okay, there we go. And of course we can also say something my mutable list dot remove at. Okay, if I say just remove, I'll have to pass the element to remove. So if I say remove, I have to pass, for instance, remove 214. Okay, and that element will remove. Let's run. And you can see we no longer have 214. However, if I want to remove by passing the index, I can say remove at index. I want to remove the first item, which will be at index 0, which means in this case it's going to be this 12. Okay, if you run again, you can see we will no longer see 12. Okay, no longer do we see 12. Very good. So you've learned about two types of collections here. We have the mutable collection, or actually we have the immutable collection, which is just a list of, and we have the mutable collection, which allows us to add items to the collection. And you also learned how to loop through a collection. So there's two ways to loop through. There's this for each, which actually is a lambda. Very cool. Actually, it gives us the possibility of using a lambda out of many other possibilities, which is very nice. You see this it or it string type here, right? And we can pass in our println or do whatever else we want. Or we can use that for loop that I showed you earlier, which is this for here. I can say item in and pass in the list. Let's do with my mutable list in this case. And now I'm going to just say println all the items inside of a mutable list. If you run this, you're going to see the numbers. There we go. 45, 123, 214. Actually, we also have that 34. The reason why it's not showing like that, let's see. Yes, because I have print, not println here. Let's say println, so that way you can see the whole picture. Okay, there we go. Now 34. So we're just printing these numbers that we have inside of our mutable list.